Artificial intelligence has become the defining technology of our era, yet most people don't truly understand what it is or how it works. In this comprehensive lesson, we're going to demystify AI completely, starting from the absolute fundamentals and building up to a practical understanding that you can apply immediately. The business case for AI adoption is becoming increasingly clear. Companies that have integrated AI into their core operations report an average of 20 to 30% reduction in operational costs. Customer service departments using AI chatbots handle 50 to 70% of inquiries without human intervention. Marketing teams using AI for personalization see conversion rate improvements of 15 to 25%. Let me elaborate on how neural networks learn. When we say a neural network learns, what actually happens is that the connections between neurons, called weights, are gradually adjusted through a process called backpropagation. The network makes a prediction, compares it to the correct answer, calculates the error, and then adjusts its internal weights to reduce that error. This happens millions of times across billions of examples until the network becomes accurate. In healthcare, AI is making remarkable strides. Machine learning models can detect breast cancer from mammograms with accuracy exceeding human radiologists, reducing both false positives and false negatives. AI-powered drug discovery platforms have cut the time to identify promising drug candidates from years to months. During the COVID-19 pandemic, AI models helped researchers understand the virus structure and accelerate vaccine development. At its core, artificial intelligence is a branch of computer science focused on creating systems that can perform tasks which typically require human intelligence. These include learning, reasoning, problem-solving, perception, and language understanding. But that definition only scratches the surface. The financial services industry has been an early and enthusiastic adopter of AI. Algorithmic trading now accounts for over 60% of all stock market trades. Fraud detection systems using machine learning analyze millions of transactions per second, identifying suspicious patterns that human analysts would miss. Credit scoring models have become more accurate and fair, extending credit to previously underserved populations. The concept of training data quality cannot be overstated. The old saying garbage in, garbage out applies perfectly to AI. If your training data contains biases, errors, or blind spots, your AI model will reproduce and amplify those flaws. This is why companies like OpenAI and Google spend enormous resources curating and cleaning their training datasets. It also explains why AI models sometimes produce biased or incorrect outputs. In education, AI is enabling personalized learning at scale. Adaptive learning platforms adjust the difficulty and content of lessons based on each student's performance. AI tutors provide one-on-one assistance to students who need extra help, while allowing advanced students to progress more quickly. Language learning apps like Duolingo use AI to optimize lesson sequences for each individual learner. The term artificial intelligence was first coined in 1956 by John McCarthy at the Dartmouth Conference. The original goal was ambitious, to build machines that could think and learn like humans. 7 decades later, we've made remarkable progress, though not exactly in the way the pioneers envisioned. The transportation industry is being transformed by AI in multiple ways. Autonomous vehicles from companies like Waymo and Tesla have driven millions of miles on public roads. AI optimizes route planning for delivery services, saving fuel and time. Airlines use AI for predictive maintenance, scheduling, and pricing optimization. Logistics companies plan entire supply chains using AI-powered forecasting. A fascinating aspect of modern AI is emergent behavior. As models grow larger, they develop capabilities that were not explicitly programmed or trained for. For example, large language models can learn to translate between languages even when translation was not part of their training objective. They can learn basic reasoning, planning, and even theory of mind. These emergent abilities appear suddenly once models reach a certain size threshold. Agriculture is experiencing an AI-driven revolution. Precision farming uses AI and drone imagery to optimize irrigation, fertilizer application, and pest control. Computer vision systems identify crop diseases and nutrient deficiencies before they become visible to the human eye. AI models predict weather patterns and their impact on crop yields, helping farmers make better planting and harvesting decisions. Today's AI can be categorized into 3 distinct types. Narrow AI, also called weak AI, is designed to perform a specific task. This is what we interact with daily, from your smartphone's facial recognition to Netflix's recommendation engine, from Siri and Alexa to Google Search and Google Maps. Every single AI application you've ever used is narrow AI. The entertainment industry has been reshaped by AI recommendations. Streaming platforms like Netflix and Spotify use AI to analyze your viewing and listening habits, suggesting content you are likely to enjoy. This drives significant engagement and retention. AI is also being used to generate music, write scripts, create visual effects, and even produce entire video games procedurally. The computational requirements for AI are driving innovation in hardware design. Companies like NVIDIA, AMD, and Google are designing specialized chips specifically optimized for AI workloads. These chips handle the matrix multiplications that neural networks rely on far more efficiently than traditional processors. The result is that AI capabilities are improving faster than what Moore's law would predict for general computing. Legal professionals are increasingly using AI to improve their AI-powered document review systems can analyze thousands of legal documents in minutes, identifying relevant precedents and potential issues. Contract analysis tools extract key terms and flag risky clauses automatically. Predictive analytics help lawyers assess case outcomes and make more informed settlement decisions. General AI, also called strong AI, would match or exceed human cognitive abilities across any task. This doesn't exist yet and remains the holy grail of AI research. Super AI, or artificial superintelligence, would surpass human intelligence across all domains. This is purely theoretical at this point and a subject of much debate among researchers. Environmental applications of AI are helping address climate change. AI models improve the accuracy of weather forecasting and climate modeling. Smart grid systems optimize energy distribution and integrate renewable sources more effectively. AI-powered monitoring systems detect deforestation, illegal fishing, and pollution in real time. These applications are critical for environmental protection and sustainability. An important distinction to understand is between supervised and unsupervised learning. Supervised learning uses labeled data, where each training example has a known correct answer. This is like studying with an answer key. Unsupervised learning finds patterns in unlabeled data without any guidance. This is like exploring a new city without a map. Most advanced AI systems use a combination of both approaches. Human resources departments use AI to improve hiring and talent management. Resume screening systems identify qualified candidates more efficiently and with less bias than manual screening. AI-powered assessments evaluate candidates' skills and cultural fit. Employee engagement surveys are analyzed by AI to identify trends and potential issues before they become problems. Learning and development systems personalize training for each employee. Machine learning is the engine driving modern AI. Instead of being explicitly programmed with rules, ML systems learn patterns from data. Think of it like teaching a child by showing them examples rather than giving them an instruction manual. The more examples you show, the better they get at recognizing patterns. Reinforcement learning is a third paradigm wherein AI learns through trial and error. The AI takes actions in an environment and receives rewards or penalties based on the outcomes. Over time, it learns to maximize its rewards. This approach achieved superhuman performance in games like Go and chess, and is now being applied to robotics, drug discovery, and autonomous driving. Deep learning takes this further using artificial neural networks inspired by the human brain. These networks consist of layers of interconnected nodes that process information hierarchically, from simple patterns to complex abstractions. The deep in deep learning refers to the number of layers in these networks. Data augmentation is a technique used to improve AI models without collecting more real data. The training data is artificially expanded by making controlled modifications to existing examples. For images, this might include rotation, cropping, color changes, and adding noise. For text, it might include synonym replacement, sentence reordering, or back translation. This dramatically improves model robustness. The amount of data required to train modern AI is staggering. GPT-4 was trained on approximately 13 trillion tokens of text, equivalent to millions of books. It takes massive computing clusters running for weeks or months at a cost of hundreds of millions of dollars. The carbon footprint of AI training is a growing concern. Training a single large language model can emit as much carbon dioxide as 5 cars over their entire lifetimes. However, the industry is making progress on efficiency. Newer models achieve better results with less computation. Techniques like pruning, quantization, and knowledge distillation reduce the energy needed for both training and inference. But here's what matters for you. You don't need to train your own AI. You just need to learn how to use it effectively. And that's exactly what this course will teach you. Federated learning is an emerging approach that trains AI models across decentralized devices without centralizing the data. Your phone learns from your typing patterns locally and only sends anonymous model updates to the central server. This preserves privacy while still improving the shared model. Apple and Google use this technique for keyboard prediction and other on-device AI features. Let me give you some concrete examples of AI at work today. When you use Google Search, AI ranks the results. When you check your email, AI filters spam. When you shop on Amazon, AI recommends products. When you watch YouTube, AI suggests videos. When you drive a modern car, AI assists with parking and lane keeping. Explainable AI, also known as XAI, is a field focused on making AI decisions understandable to humans. When an AI rejects a loan application or diagnoses a disease, we need to understand why. Techniques like attention visualization, feature importance analysis, and counterfactual explanations help humans understand and trust AI decisions. This is especially important in regulated industries like finance and healthcare. AI is also transforming industries. In healthcare, AI can detect cancers from medical images with accuracy matching or exceeding human radiologists. In finance, AI detects fraud in real time, processing millions of transactions per second. In manufacturing, AI optimizes supply chains and predicts equipment failures before they happen. The field of natural language processing has seen remarkable advances. Modern language models like GPT-4 and Claude can write essays, code software, analyze documents, translate languages, and hold coherent conversations on virtually any topic. They can summarize books, generate creative fiction, and even help with scientific research. Computer vision has progressed equally dramatically. AI can now recognize objects, faces, and scenes in images and video with superhuman accuracy. It can generate entirely new images from text descriptions, create realistic video, and even generate 3D models from 2D photos. The economic impact is enormous. McKinsey estimates that AI could add up to $4.4 trillion annually to the global economy. Companies that adopt AI early are seeing significant productivity gains, while those that delay risk being left behind. However, AI also faces important challenges. Bias in training data can lead to unfair outcomes. Privacy concerns around data collection are significant. The energy consumption of large AI models raises environmental questions. And the potential for job displacement requires careful planning and policy. Understanding these challenges is just as important as understanding the technical capabilities. Responsible AI use requires awareness of both the power and the limitations. In the following lessons, we'll dive into practical tools like ChatGPT, advanced prompting techniques, image generation, and building complete AI workflows. By the end of this course, you'll have a comprehensive understanding of how to leverage AI for your personal and professional goals. AI isn't coming. It's already here, and it's already transforming every industry. The question isn't whether AI will change your work. The question is whether you'll be the one using AI or the one being replaced by someone who does. This is the most important technology of our time. Understanding it is no longer optional. Let's dive in and master it together. The human element in AI development is often overlooked but critically important. Behind every AI system are teams of researchers, engineers, data labelers, and ethicists working together. The quality of an AI system depends not just on its architecture but on the judgment of the people who design it, the data they choose, and the values they encode. This human-centered perspective is essential for responsible AI development and deployment. Looking ahead, several trends will shape the future of AI. Multimodal AI that combines text, images, video, and audio will become standard. AI agents that can take actions in the digital and physical world will emerge. On-device AI will bring intelligence to edge devices without requiring cloud connectivity. And AI safety research will become increasingly important as systems become more powerful and autonomous. The democratization of AI is perhaps the most important trend of all. What was once available only to large tech companies and research institutions is now accessible to anyone with an internet connection. Open-source AI models, cloud APIs, and user-friendly tools have lowered the barriers to entry dramatically. This means you, regardless of your background, can build with AI. And that is exactly what this course will empower you to do.